Sets. So this session will be mainly dedicated to unmanned aerial vehicles and systems. This topic is trendy now. It's interesting, and we did not single out a session on UAVs during previous conferences. Now we believe that this subject is too important to overlook. So it gives me pleasure to introduce to you the first speaker, the General Director of AFM-Servers, Amir Valiev. Company is well known in Russian market. We believe in the field of mapping, our primary focus, AFM service delivers the most professional results. I also would like to say that Amir is also the president of Airbus Association. We have Airbus Association. I wish we had Mr. Bertolini here, but it's an abbreviation of UAV in Russian. Please, Amir, the floor is yours. Good afternoon, dear colleagues. First of all, I would like to say thank you. Thank you to Viktor Adrov and to his staff. This is the second conference I have been able to attend. Well, there is no need to praise the conference. Maybe it's even inappropriate to praise the conference because this is self-evident. On my first slide, I wanted to show a range of tasks to be addressed by UAVs. These are 5 main areas that are mostly capitalized now or will be capitalized in the future, showing shares of market and ratios now and 10 years from now, assuming that the annual amount of services will be worth at least $100,000. $100 million. Now it's around 10 million. So diagnostics of linear objects and large areas has become one of the separate areas where UAVs could be of use. Then pipelines, oil and gas, protection, search and locate UAVs that used to be used in the military sector. Now they become more civilized. And cargo delivery. It seems like cargo delivery or shipping has little or nothing to do with the current range of tasks like mapping and land survey, but it's not. You have to use certain coordinates to deliver your cargo, and laying out the route, laying out the strip based on those coordinates is a task for remote sensing. So what technologies are available and applicable to UAVs? These are the examples already in common use. Some are only starting, but there have been some precedents. As for ortho survey and oblique imaging, it's obvious. I will elaborate on laser scanning, radar imaging, the development of military technology made these sensors available for the civil market. uh, gravimetry, magnetometry, and other areas where UAVs may be of use. Now, talking about sensors, it's unusual uh, to see IMUs here, but these are the sensors that can help you reference data that you may receive. I mean, visual range, infrared range, SAR radars, LiDARs, and devices for gravity survey and magnetic survey. So I'm going to elaborate on what methods of data processing we have used. So the first list here will be dwelt upon later in my presentation. Also, our customers set requirements that they need. For example, one of the tasks was to have 70,000 images, 3.5 gigabytes a week uh, per 700 kilometers, which generates a lot of data that needs to be stored somehow. And for that, you need to have databases, GIS systems. We believe that there must be some methods to visually analyze by expert, because automatic systems cannot make decisions. But remote sensing technology should help reduce significantly the amount of data to be analyzed. These are the flaws and disadvantages of UAVs at the moment. Some of them can be addressed now, others are very stubborn, and they may be resolved by using lightweight or heavier weight vehicles. One of the key challenges is legislation. As an aside, I can tell you that we were the first company to start flying in 2009. We broke the law by doing that, and they caught us. We got caught, so I had to go through law enforcement gauntlet, including FSB, Federal Security Service. Now they're great pals with us. So, however strange it sounds, now our legislation is much better worked out than in any other countries. There's been an interesting event recently. We provided our UAV to Mexico. This is the first time we had a purchase in Latin America. We found out that there are rules to use airspace, and these rules are much more stringent than in Russia. Small vehicles in Russia and CIS are not presented in large numbers, unlike in the Americas, Australia, Europe, where jointly with ICAO, to make sure there are no collisions in air. At the moment, it is important for small aircrafts to see UAVs, so there is always a risk of collision Tomorrow we'll have a round table to discuss in great detail all the aspects of this subject and to see what can be done. One thing is for sure, using UAV is not just a trend. This is a large business sector generating revenues, and we must keep it, we must be on top of it to resolve the problems in this field. Another problem here is that sensors provide a lot of images because when you apply photogrammetry, there are a lot of errors building up. Secondly, because of small size of vehicles, there is no compensation of side of wind impact, and also there may be pitch deviations requiring the need to compensate the side overlap, increased side overlap. Any vehicles weighing less than 10 kilograms suffer from image variances, which drives the need to have a repeated flight. This also causes the problem of blurs. Also, there's a problem of using slit shutters. This is the type of shutter where a recording is made layer by layer. And when the camera is in the air, some distortions can be caused, resulting in poor accuracy. Now CCDs have been replaced by CMOS matrices or rolling shutters. The use of household cameras is practically non-existent now. Well, actually, for more lightweight vehicles, such amateur cameras can be used. I can give you an example of one such camera, which is used with a special attachment. So when they change lenses, they have to recalibrate the camera. This is a professional camera costing around 50 to 60,000 euros, and such inconveniences cause surprise among those who use these cameras. Also, UAVs have short flight time. Most of them use batteries, so they fly less than 2 hours. There are some vehicles that can fly longer, but their reliability deserves much more to be desired. But this is an area which is now being addressed increasingly. Actually, UAVs cost a lot of money now. So these are the image distortions that happen when you use a plane shutter. To synchronize with flashlight, you need to have 1 to 250 thousandths second, and that leads to accuracy loss by 3 to 5 pixels in plane and 6 to 10 pixels in height. This is somewhat exotic, This is where we used a flashlight in the visible range. This dates to 2010. We're now working on a new flashlight that will allow using flashlight from 300 meters. It's okay to fly at night, it's not against the law, and it may be even more convenient to do than doing it at daytime. As for SAR radars, this is good for locating sunk ships or sinking ships. It has high capacity rate. This shows at a summary table of acquisition rate. In 6 hours you can survey a territory of 1.5 thousand kilometers. This is very relevant for Russia. In the past few years there were many cases, several cases of missing aircraft, and using UAVs those aircraft could be found, because under other circumstances it takes up to 2 years to locate such planes. With UAVs you can have low height flights. You can also fly under complicated weather conditions, which is impossible for a manned vehicle. Also, UAVs take many images from various angles, which is good for fullness of picture. Here the size of pixel is about 1 centimeter. These images are not used for mapping applications, they're used for visual analysis only. Here's other examples of how you can detect places of wiring being connected in places of breakage. These are wintertime images, not typical for people present here, but in Russia we do get some winter days. This is an example of fallen trees that landed on power lines. This is where I'd like to elaborate a little more. Data processing. Automated photogrammetry is being used increasingly. Previously it was manual. There are automated methods of 3D reconstruction. Not only can we get transformations, but also trees or areas where you need to have clearings between the road or the power lines and the trees, and this is where UAVs can be of help. To do a more accurate analysis, it is better be done visually. By combining automated and manual approaches, you can receive high productivity data. As for visual reconstruction with sagging power lines, it happened to be a fairly cheap solution, because it's impossible to scan lines with other methods, because it will cost a lot of money. If we take a photomod product and modules that come with it, you can use it with better efficiency and less expensive. As for the other 3 methods of processing, we can see that some of these methods need to be done initially because first you have to get high quality data, and the red color shows that photogrammetry experts are requisite here. As for regular surveys that can be done by owners or users of UAVs, there are such techniques as norming and norm setting and spatial referencing, so you can reference images to have a fast selection. So first you need to have a geo-referencing exercise to get spatial coordinates for each object of the line. If you have an onboard IMU, you can use photogrammetric method that will require a lot of resources. And then you can provide this data to an engineer, and the engineer, out of 100% of data, can select a small area and view only the necessary portion of it, increasing labor productivity and possibilities to use the line cheaply. But for that you need to do preliminary data processing. We found that automated image processing is a difficult thing to do. You can also discard elements that you don't need, like forest, so that on your image you have things that you need. This helps to stay focused on your goal. This is a picture of our plane that we provided to Mexico. I mean UAV, Ptero GO. It's gas operated, petroleum operated, and it can fly up to 8 hours. It is catapulted into air and then it lands on parachute. Some of our customers use it in low visibility areas, but they haven't lost a single one. We lost 2 during initial testing. I will talk about it tomorrow. What other characteristics does this plane have? Since we're flying at low altitudes, we have to monitor it all the time because it quickly disappears from range of vision, especially when mountains are involved. So, coming back to what I explained earlier, Sistemas Avanzadas y Proyectos has shown interest in our product. The owner of company boldly traveled to Russia, looked at all the UAVs available, and purchased our plane. I can't say that this is the best in Russia, but I think it's an appropriate plane for him. We were somewhat afraid to go to Mexico. I can't say that it went without snags, but there are certain results, and the director was pleased with them. I hope that in the near future, apart from training, we will also have an agreement on providing other.
Here you can see an example of how we process the data. For that we use PhotoMod. This is an extraction of orthophoto with an increased depiction of power lines and the crisscrossing of power lines with the road. Here you can see a table that I would like to draw your attention to, but unfortunately I don't have much time left. I will skip to the second part of the table right away, and I will tell you that here you can see the comparative analysis between two satellites. This is an electrical UAV Geoscan 1, which is well known in Russia, and our UAV TRG-1, which is in its specs is almost identical to TRG-0. Main conclusion is that if we look at the bottom row here, then the unit cost for the imaging for the owner of the UAV is about $7 per square kilometer in case of electric UAV, and about $5 in case of using our apparatus. But there are certain conditions when this works. On the next slide you can see that there is a line like this. This is the cost of image acquisition by our class apparatus, and starting from about 15-20 square kilometers and up to about 300-400 square kilometers. It is the most profitable for aerial photography. Here you can see an example of the interface, how we do the flight planning. This is where I calculated the productivity that I used in those tables. Tomorrow we can look at them in greater detail. Speaking about characteristics, the unit cost for electrical unit is $2.5 for square kilometer, and for our plane $2. Another thing I'd like to brag about is that we started joint development of LiDAR for our UAV, not only for it. The main principle behind this LiDAR is 8 measures concentrically positioned, and they're rotating at the 30-degree angle. And during the flight of the plane, it goes round and round in concentric circles. And because of the lack of the mirror, here we have the maximum rigidity of this system. Here you can see the characteristics of this LiDAR. The imaging daytime from 700 altitude, 700-meter altitude, and the spot on the surface of the Earth is about 15 centimeters. And if you fly at night, you can fly higher because the solar radiation would not interfere. And now we're at the level of experimenting with this, with the optical part. As far as the electrical part is concerned, we have completed our experimentation, and the accuracy that we can ensure, you can see it here. At a flat object, it is 20 centimeters, and a disseminated or complicated object is about 15 centimeters. We have 8 measurement channels, a very interesting configuration. The weight of this LiDAR is not going to be over 3.5 kilos. Why we start to develop it for ourselves? Because of the start, we have 15G and the scanners which exist on the market cannot survive this type of velocity. I think I was within my time. Thank you very much, Mr. Valiev. A very interesting presentation indeed. Dear colleagues, any questions? And then Mr. Valiev, while colleagues are thinking about it, indeed, the legislation is very different in Russia and the world. And in that case, Russia proves to be more humanistic than other countries. As far as I know, in Hungary, you cannot use UAV over labs, and you cannot use UAVs in terms of doing the work beyond the direct vision line. Are there any local restrictions when you cannot fly over some particular objects in Russia, or when you cannot fly over certain distances? So what are the existing restrictions in Russia in terms of technology? And the final There are no real restrictions in Russia. You can reserve an airspace of any size, actually, in Russia, both daytime and nighttime, even over such areas as Moscow. Recently, we had a precedent when we received a flight permission for aerial photography over Moscow for quadrocopter. We explained what kind of area we're going to do, although over Moscow usually they prohibit to use such lightweight apparatus over Moscow. And based on our experience, we never had any problems with aerial photography, and there are no restrictions neither on the distance or where we fly. We even flew not far from the nuclear power plant. We just told them that we're going to fly not far from them, that we were given this permission. There are, of course, certain restrictions related to the proximity of military airfields. When we were acquiring images of Kubinka, and they have a military airfield not far from them. Dear colleagues, any more questions? I understand English, no problem.
Дай другой микрофон.
Раз. Вот работает.
Это не работает.
Hello, yeah. Okay, this is working. I do have a question about the design. We have two aspects actually what you mentioned. First is the airplane, the UAV itself, and it is you use a catapult, and in order to come back on the ground. In order to come back on the ground, you need a parachute. The laser scanner you are developing is actually built around these restrictions, especially with catapulting. It has to resist some 20G. And I wonder why it would be necessary to design a sensor completely on the design of the UAV. Another possibility would be to redesign your UAV.
Я понял вопрос, спасибо. Дело в том, что коллега действительно прав.
I understand the question. The colleague is right. Maybe it doesn't make sense to develop laser scanner. Instead, it's better to change the design of the UAV so it doesn't destroy the scanner. We had such an idea, but the situation is such that we're not really developing laser scanners to avoid the problems with catapult. We just did it thinking that we can do this, and the fact that it can survive 20G, that we have this, it is, but that's an added value that we have acquired. So it's not that we develop sensor because there are no laser scanners which cannot be carried by our UAV. It was just a fun project for us to do. We think there is a market opportunity for it. I would like to ask the following question.
I understand English, but don't understand Spanish.
We would like to find out, you were saying that you wanted to sell these UAVs here in Central America, in South America. That is why I have the following question. You do know maybe the pricing of this UAV here for Latin America. Just give us a ballpark figure, an average figure. The price was quoted on the slide. Now our UAV costs about $85,000 US. without GPS receiver. And to enable it to fly 500 flights and landings, you need to spend $15,000 on the life cycle of the actual plane. So the overall apparatus plus its maintenance for the flights is about $100,000 in total. But the last 15 would be spread for 4 or 5 years of the life cycle of the plane. Any more questions? If there are no more questions, I would like to thank Mr. Valiev. And now